So also in the section, as well as proteins, we also have to cover enzymes, because enzymes are proteins, so it makes sense that they're falling into this category too. And enzymes are biological catalysts, which means they're speeding up reactions without themselves getting used up in the process. They're lowering our activation energy for us. And you can see here in this diagram how they're lowering an activation energy. So if that's the uncatalyzed reaction, we've got this alternative pathway of lower activation energy, and it's via this intermediate. And the intermediate here is going to be called an enzyme substrate complex. Right? And so the idea is that the substrate fits into this very specific site, and we can think of that as a lock and key coming together, or more recently people have developed that to this idea of the induced fit, where it goes in and then when it fits in, that actually helps the catalytic process. So you can see coming up some examples of active sites, and you'll see certain key residues coming out and helping with whatever catalysis takes place in that enzyme. So here's chymotrypsin, breaking a peptide bond there. And again, looking at the active site, you can see just how specific it is based on its shape. So you've got this hydrophobic binding pocket where a group like that is going to go in, and then you can see there that's going to fit that nicely. And then in the active site, that's where we're going to start to get the actual chemistry occurring there. So it's got to fit in before we can undergo that catalysis. Now, for that catalytic process to happen, there are certain kind of optimum conditions for our enzymes to work at. If you think of your body, you're obviously very sensitive to significant changes in temperature, significant changes in pH, and maybe you've come across this idea of sort of poisoned by heavy metal ions. But if we think of, I don't know, the enzymes in the mouth's about 37 degrees. Obviously, salivary amylase must work well at around about that temperature. We can see general kind of reaction kinetic idea that as temperature goes up, we get a faster rate of reaction. But there comes a point where it's not like a chemical reaction where it continues. We end up with the activity dropping right off. And at this point, we can say that the enzymes become denatured. We talked about that because of the disruptions to the hydrogen bonding and its shape changing. Similar ideas with the pH. That's also going to affect our hydrogen bonding. Different enzymes will have different pHs that they like to work at. So in your stomach, pepsin enjoys an acidic environment. Glucose 6-phosphatase is working more at a pH of 8. But you can see outside of those conditions, we're starting to see the enzyme become denatured. And the last one, the heavy metal ions. Those heavy metal ions are going to affect the cysteine residues, and as a result, that's going to have an impact on, again, the structure of our enzyme.